Good evening to all. So I just started the recording of this. I am audible to all?
Yes, sir.
Okay, okay. So today we'll have the some part of. Bharti, can you hear me? Okay, so today we'll have a three part. Some part I will be doing these presentations, and the first part will be presented by the group two. Then I think Bharti or Om Prakash they will be presenting the field tour. After that, I'll be presenting the remaining braided river concept as well as one case studies on channel instability. So that way, we can divide the timing, and as well as I always encourage, please ask the questions, okay? Because it's an online mode. It is a good to, if you start interactions. So otherwise, in online mode, whoever be speaker, he doesn't get encouragement unless otherwise you ask the questions. So that's the reasons. Please ask the questions so that we'll have a discussion. This is the interaction classes. So that is what we can always ask the questions. Then we'll have a uh, discussion on that. So we have a three components. The first components will be presented by the student group. um, I think group two, I think, who are they?
Yes, sir,
Anjali.
Anjali.
Anjali, and from
Sir,
online,
Sompriti.
I think, who is there? From online, who is there in your team? Anjali? Anjali, can you hear me?
क्या सर सर
Yes, sir,
नहीं
audible, sir.
पता नहीं
Uh-huh. Jaideep Goswami, or who is there from online for the group two?
Sir, me, sir. I just joined.
Okay, okay. Okay. Near Jyoti Gogoi. Okay, that's good. So that way, I think now the number has reached to 22. Uh, who will start it? Anjali, just share the PPT and start it. Or Neha Jyoti Gogoi, who want to start the presentation? Yes.
Anjali, you please start. And I am connecting through my cellular phone. I am not using
Sir,
my laptop.
sir, me, Sompriti will be presenting.
Okay, okay, good, good. You start presenting it.
Okay, sir.
Start presenting. Share the PPT and start discuss. Yes, I can see your screen. Put it in the full view mode. Yes, it is
Yes,
there.
sir.
Now you start it.
Okay, sir. So good evening, everyone. Myself, Sompriti Thakur from Group 2, and here we are presenting the presentation uh, of the case study 2. This presentation is based on a research paper that studies how dynamic the Brahmaputra river is. It explains how the rivers flow and landforms. Sorry, sir. River flow, landforms, and vegetation work together to manage the river's enormous energy. Here, the Brahmaputra is one of the world's most dynamic sandbed braided rivers. It Its behavior depends on flow of water, sediment movement, and vegetation growth. These three together controls the channel shifting, fire formation, and instability.
Yeah.
Hello, sir.
Continue.
Yes,
Are you
sir.
feeling well or something?
Sir,
Okay,
actually, I'm a
sir.
bit sick.
Uh-huh.
Okay, sir. I would like to speak about this slide.
Okay, please,
Okay,
please.
as you all know about that, our Brahmaputra River is one of the most dynamic river of the world. This river carries very high ditches and sediment load from the Himalayas. Although the slope in the Assam plains is gentle, the volume of flowing water generates very much of excess amount of energy. So this excess energy causes bank erosion, channel migration, and braided channel patterns. We all know that Brahmaputra is a very big braided river. So such instability is a natural response to high energy river conditions. So this slide is all about all these things. And in energy the distribution triangle in the Brahmaputra mainly occurs through three interconnected processes. There are three interconnected processes here. These processes include widening of the braided belt, then the formation of the sandbars. We all know that Brahmaputra has made so many numbers of huge sandbars, and people used to live there. Their schools are there, and development of riparian vegetations. There are so many vegetation in Brahmaputra River. We all know about that, and each of these three processes influences the others. They are dependent on each other. They are not independent of each other, forming a continuous feedback system. So this triangle explains how the river adjusts itself to reduce the energy. So this is it in this slide. And here the mobile about this mobile braided belt. At the largest scale, the river dissipates energy by expanding laterally across the floodplain. As we all know that the width of the Brahmaputra river is not same everywhere. So width of the Brahmaputra in Palasbari Gumi area, it's almost like 18 to 20 kilometers. But in Saraiঘাট, it's so narrow. It's like a deep gorge. So the braided belt will vary significantly, sometimes extending about several kilometers, like I have already told this Polasbari Gumi area. So this lateral expansion reduces the flow intensity but leads to severe bank erosion. So it is the primary mechanism by which our Brahmaputra river manages excess amount of energy. So this is it in this slide. And there is this temporal change in instability. We all know that back in 1950, there was a big earthquake, which we know by the name Assam earthquake of 1950, and there we all know that the entire Brahmaputra floodplain was shaken. Not only the Brahmaputra river was affected, but also its tributaries, especially the northern tributaries. They all are affected. They all have become shallow. I myself, a, native inhabitant of Dhemaji district, I know how river behaves there. They It's like total madness in during peak flood season. I have seen it since my childhood, and it's very dangerous. If you haven't seen it with your own eyes, you will not believe it. So generally, This 1950 Assam earthquake increased sediment supply to the river. This resulted in rapid channel widening and extreme instability. But over time, the river showed partial recovery, followed by renewed instability. But later, the Brahmaputra River has again, uh, it's not like stable now. It's again doing very much activity. It's expanding its width and all. So this is it from this slide. So in this slide, we are talking about complexity and disorderness. The Brahmaputra River further dissipates energy by increasing channel complexity. There are multiple channels are there. There are frequent bifurcations are there because of these sandbars which are there in the middle of Brahmaputra River, and this and shifting sandbars increases the flow resistance because we all know that during every flood and before flood and after flood, the picture totally changes. The sandbars which were there before flood, they are not there after the flood. This leads to higher turbulence and frictional losses. As a result, excess energy is displaced within the channel network. Next. So here there is flow bifurcation process, and actually I would like to know from sir actually this asymmetric bifurcation. There are degrees and angles are there, but I am just trying to explain it. So when river flow encounters these sandbars, it splits into two or more channels. Balance or symmetric bifurcation promotes stability. Unbalanced or asymmetric bifurcation increases instability and erosion. Therefore, this bifurcation geometry strongly influences channel behavior. But this about 30-degree angle, 45-degree angle. So if sir explains it, then it will be very helpful for all of us. So next slide, please.
Okay, so basically I'll be talking that part, but about the mega channels also we can just have a discussion. Can you hear me? Can you just hear me? Just to put the previous channels. See, if you look at the Brahmaputra, this is a very interesting data what we have shown it here. Okay. This is called water occurrence map. This is what generated by considering all the satellite data from last 1970 onwards. Wherever the water is there, they give it the percentage of occurrence. If it's 100%, that means channel anyway it is there. In the last almost 20, or can say that almost 45 years, 50 years, the channel is more 100% is there. But as you have these colors, different colors we have, that indicate the channel presence are less. If you plot that is a clear cut indicating there is river has a spread, but there is a active braided belt. That what the exact word we brought it. See, that is a mega channel. This mega channel, as the literature said, before the 1950 earthquake, Brahmaputra has to be a meandering river with having a width of 3 to 4 kilometer only. It's a meandering river. After that, it became the braided river, a 1950 earthquake. So that is the reason these active channels we are able to get it, which is a meandering channel. If you really digitize these channels from Sadia to up to, I don't stop any study up to Dhubri because that doesn't make a sense. So if I can go up to the Bangladesh and at the confluence of Ganga and Brahmaputra, you can really look at this active braided belt, actually a single channels of meandering channel. having a width of the 3 kilometer to 4 kilometer range. So that word is there. Before 1950, great earthquake, the Brahmaputra was a meandering channels of a width of the 3 to 4 kilometer. So that's the reason it was a navigable channel. That is a reason a lot of navigation activity was there before independence or before the formations of Bangladesh. So before independence, these channels were the navigable. The people used to come from Dhaka through these ones, but now it's not navigable because of this multiple braidings what is happening. So this channel, I think more details, this is what we are looking at. This is mega channel active braided belt, which is active actually. This is what on average of 3 to 4 kilometer width. You can go for next. Regarding unsustainable bifurcations, I'll look at the paper what he has written it, how the flows is. But if you try to understand it, if the symmetry bifurcation is a more stable, because you can understand it in terms of the specific energy steam powers, okay, unit steam powers or specific steam powers, if both are the same length, then energy loss will be the same. So that's the reasons symmetry bifurcations are the stable configurations, but non-symmetry bifurcations are not stable configurations because there is a unbalance between energy loss what is happening or the steam powers, unit steam powers from this point to this point. So that what is unsymmetric bifurcations is unstable, but symmetric bifurcations are stable. Regarding this 30 to 45 degree, I have to also relook the papers, okay, what Ketan has written it. Okay?
Thank you, sir.
Let us go for next slides.
Yes, in this slides, it's talking about geomorphic units and their stability. Though sandbars can be categorized into mobile free bars and stable force bars. Mobile bars shift frequently, as I have already told about this pre-flood and post-flood scenario. So these mobile bars, they shifts their sizes and shapes, they all changes after the end of this flood period. So they frequently contributes to the instability. Force bars, especially when stabilized by vegetations, reduces local flow energy. This geomorphic units controls the river's morphological behavior. So next slide. So this slide is talking about the vegetations which are there in our Brahmaputra river. So these vegetations plays a significant role in shaping our river systems. So plants growing on sandbars, they trap sediments and increase this surface roughness. So this reduces the flow velocity and promotes deposition. Over time, vegetations convert these temporary bars into stable bars. So, like I have already told that there are many these bars are there in Brahmaputra River where people actually lives actually. So and uh, actually this vegetations helps a lot. Please go to the next slide. So this slide is talking about island to bar ratio. So the island to bar ratio is used to assess the stability of the river system. So higher ratio indicates that there's increased vegetation cover and stable islands. Lower ratio suggests that there is dominance of mobile sandbars, and uh, from it we will know that there exists higher instability. So this parameter provides a quantitative measure of river conditions. So in the integrated energy distribution system, so the Brahmaputra dissipates energy simultaneously at multiple scale. So large scale channel widening, sandbar dynamics, and vegetation resistance act together. This integrated system allows the river to manage extreme discharge conditions. It demonstrates the self-organizing nature of our Brahmaputra river. Next slide. So the future reach scope is that the future river management should focus on improved data collection and modeling techniques. So including vegetation's effects in numerical models, in particular, is particularly very much important. So there should be nature-based solutions which must be prioritized for sustainable river management. So there must be room for river. We should not construct embankments. So constructing embankment for me, it's a time bomb. It's a ticking time bomb. The river beds are increasing every year, and the river side bed elevation is increasing, but the countryside bed elevation is it's not increasing. From where I belong, there is a river called Gainodi. So I myself surveyed it last year. I found out that the countryside is almost 2 meters. It's almost 2 meters below the riverside. So those embankments are actually taking time bomb. When when there any kind of breach will happen, almost 7 to 8 villages will be totally affected. So there must be room for river. We must live with river. We should not confine it. So please go to the next slide. So, so finally, we have reached the conclusion. The Brahmaputra is inherently the most dynamic due to its high energy and sediment load. So, attempting to fully control the river is neither practical nor sustainable. So, we must understand the energy dissipation mechanism, which is very much essential for effective management. We must manage our Brahmaputra river. We should not fight against it. So, fighting a river, it's not possible. It's nature. Art has been here for a very long time. We are here for a very short time. So we must live with nature. We should not try to contain it. So respecting natural process is the key to long-term river stability. So thank you all. This is from us.
Can you give a big clap to him? I think I feel proud that the person from Dhemaji is presenting this work. Okay, it's because I started career from Dhemaji. Okay, long back in 2005, I went to Dhemaji. Okay,
Yes, sir.
to reach the Dhemaji in 2004, 4 or 5. Okay, it took me a huge time because there was no road existing. Okay,
Yes.
we stayed in a Demaji circuit house. Okay, so that's what that is what my career of Brahmaputra River started from Demaji. Okay, so long back, 2005 or 6, there was a invitation from DC office to huge bank erosions happening it, and they were doing some work, but it's not that. But where these people they really welcome us in different way. Okay, so but uh, I also went in Demaji is the last I think last year, but things has changed. A lot of things has
Yes,
changed.
sir.
Road
Things, lots of things
connectivity
has changed. The
changed
connectivity has
compared
improved,
to
sir.
yes. So, but still, as you said it very clearly, that the flood and bank erosions in Dhapanji will go on, but we have to live with that nature. That is what that instead of confining with embankment, which is as you said, it's actually we can I can say it is a as a hydraulic specialist, as a river engineering specialist, we are doing a blunder mistake. We should not do any embankment of this type of river system.
Yes, sir. It's true, sir.
So we, even if you want to do it, then we have to have very much different strategy for that. Okay, which we should have a different strategy. It's not a traditional embankment, putting the embankment very close to the rivers and telling it we can find the things. So that's what will be things. So I think I really happy that from Dhemaji you are from born and brought up in Dhemaji. You read this paper, and which is one of the best paper from my research group. Okay. And so we are advocating it the things we should understand the river first. After that,
Yes.
we go for the solutions. Otherwise, investing large money, no meaning. It doesn't suffice that. Or other way around, the constructing embankment is a much more liable to the state waters department, because anytime breaching can happen. It okay, so it is a not protecting. It is a reverse things are happening. So that way, but I think I'll commit a more discussion is that how we should do the embankment, how new techniques, what way we should follow it. Those discussion I'll commit. Okay, at least we can put it that discussion. So anybody have a questions? One or two questions I can encourage it. Please ask the question. As you ask the question, you will also get the mark. Okay. It's not a mark for only who present it. Yes. Yes, just ask the questions.
Sir, how do bifurcation and confluences dissipate energy?
Okay. Yes. Yeah. Gogoi, can you reply to him, or I'll come back? Niyajati.
Yes, sir.
Ah.
Please repeat the question again.
My question is, how do bifurcation and confluences dissipate energy in the river?
Regarding this confluence, from what I have seen in the field, I cannot answer it in detail, but regarding this confluence, so what I have observed that these tributaries brought so many sediments. There are so many tributaries in Brahmaputra River. So in the tributaries brings so many sediments. So these sediments are deposited uh, in the Brahmaputra River. So, by depositing these sediments, they dissipate uh, this energy.
Yes,
So,
sir. And they create the turbulence. That's why the friction loss is increasing.
I'm audible.
Yes, sir.
yes, sir,
Okay.
yes.
Apurva, you have asked a very good questions, which I maybe in the next class I will show you that when you river is bifurcating and confluting it, how these turbulent structures are making it, how the vortices is there. If these turbulent structures are happening it, that means additional energy dissipations happens it. So there are the papers are there how this confluence and the bifurcations dissipate the energy. They are dissipating the energy because of the turbulent structures what it creates. The like a secondary current what we are studying in the class. The same way channel bifurcations and confluence also secondary current it fermented. That's the reason a lot of energy dissipates happens it. Any other questions? Yes, please ask the question. At least you'll get a mark now.
Sir, in previous slide, they show IBR ratio, Iceland to bar ratio. Like, can you elaborate
Yes, yes.
Yes, sir.
Go ahead.
It is the ratio of number of vegetated islands versus the bare bars. So here, as you can see, the high range of IBR refers to more morphological stability.
Ratio of what?
The ratio of vegetated island versus the bare bars.
Bare
The
bars
island which is
means the
vegetated, as you
yeah
can
the
see, uh,
yeah, yeah
the darker
those
green
islands
colors.
were dead doesn't have these vegetations.
Oh, okay. Okay. Thank you.
Basic hypothesis is there, the bars with a vegetation are stable. Bar without vegetations is unstable. So that two ratios are island to bar ratios. If you look at it, it has divided to number of zones. Zone 1, zone 2, zone 3, zone 4, like this. Okay. Then it is finding out this IBR ratio. So if it is highly island braided, zone 4, 6, 8, 156 then, and what is the braided belt width? You just look at 10 to 11 kilometers. And where is bar? Is it 3 to 6 kilometers? So its dimension of the rivers Brahmaputra is really fantastic in terms of the scale of understanding. Any questions for that? Good. I think is have a clap to them again. Okay, virtually. And good, 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 good. Okay. So after this, we'll
Thank you,
have
sir.
the present. Thank you, thank you. Okay, so others be prepare it. Okay, like group 3 be prepared nowadays. Also read the paper so that the questions what will be asked it at least to be ready. Okay, whoever the group 3. Okay, who are there in the group 3? Group 3, who are they?
I am Himanshu. And
Okay.
Apurva.
So group 3 paper I'll give it and these things. So please read it and go to the
Okay,
next
sir.
level. Huh? So
Okay.
that at least we can have a discussion level for technical discussion level.
Okay, sir.
Okay, so with this, Bharti, are you ready for presentation?
Yes, sir. I'm ready.
Sir,
Okay.
should I
Okay.
stop?
You can stop sharing.
Huh? Am I visible? My screen is visible to you all?
Yes, it's visible. Put it in a full screen mode. नीचे एक ये है फुल स्क्रीन मोड का है. Yes.
Can I start now?
Yes, you start it.
Yes. Good evening, everyone. As we visited the site near Bogeyville Bridge, so this is the Brahmaputra River, and the first image you see here is the sand dunes. The image is visible to everyone. Hello.
Yes.
Okay. This image here is sand dunes, which is formed on the Brahmaputra River. These are formed when flowing water moves sand grains and deposit them rhythmically. As the Brahmaputra carries huge sand beds, you see here are this is also a sand dunes, and here you see this sand dunes and this one. These are totally different. This is like a plain sand bed. The surface looks smooth and flat with no ripples, indicate a plain bed condition. Such bed forms when flow velocity is relatively higher than ripple forming flow. Then next image is riffles. This is called riffles. Riffles are shallow, high velocity ridges formed by sediment accumulation and wave form development. Now, next image you see is bundling. Here you see the bamboo. These are in a row. This is visible to you all. Hello.
Yes.
Yeah.
You can see the bamboo here. Is this bamboo visible? These are in a row, which is bundling is in bundling we use bamboo, which is also cheap and economical. It is installed inside the river or along sandbars to divert flow, reduce velocity and to control erosion. Here bamboo poles are driven into the river bed in rows. Uh, here you also see the bundling. These are bamboos, which is used to divert the river. And these are geobags near the bank of the river. Uh, these are okay. Uh, this is bank erosion, which is you can see the vertical cut here in the near the bank of the river. This bank erosion forms when high velocity flow undercut weak alluvial banks cause toe erosion. Means here first erosion is start from the toe and this cause the unsupport to the upper part of the soil and that cause the vertical cut bank. Here you can see that this the bank is a vertical cut. And now these are geobag, which is used in the near the bank of the river. These are the sand-filled banks made of geotextile fabrics. It is used at river bank to prevent soil erosion and stabilize slopes by acting as a protective shield against hydraulic forces. Here you can see the geobags, which is used in the near the bank of the river. So these are all are the images we found out near the Bogeyville Bridge. Thank you.
Yes, can I have a okay? Uh, Give a clap to him, her. So good, good, good. Any questions? Or I'll be. Please. Please ask the questions. So I was also part of this. I think field tour where we conducted a survey just upstream of the Buggyville. Why we have done it, we are not telling to that true things, but this is a part of Inland Waterways Authority of India. So we did a survey and we also submitted the report to Inland Waterways Authority of India. So really, I will tell it the issues as you know it. This Brahmaputra rivers. Okay, it is changed the morphology. Because of boggy wheel constructions, now that effects are visible. Okay, some are the effect of the boggy wheel on the river morphology at these boggy wheel locations. That bridge effect has come up, so that is also quite visible now. The upstream of this boggy wheel bridge, the morphology is suddenly changed. We have all the satellite data. We analyze that data. Something in a concrete form when you will be there, I will also share with you. So just a constructing a boggy wheel, which is a 5-kilometer length. So you are not confined the channel, but still it has responded. So that's the reasons the river has responded. Other things what I don't know from this online program, anybody is from in charge of the Diburgarh Water Resource Department is here now? Or Dhemaji or anybody from Water Resource Department of Diburgarh?
Sir.
Yes.
Sir, since my hometown is Dhemaji, so I know about that area very well. So before
Yes.
Bogibel Bridge, the Brahmaputra River was it was not narrowed. So now this
Yes.
Bogibel River has narrowed the river specifically, especially at that point. So
Yes.
that indeed the Bogibel Bridge is very lengthy, but it's not enough for Brahmaputra River to flow. So
Correct.
my concern is that in future, as the Bogibel Bridge has narrowed the Brahmaputra River at that point, it will affect the downstream area. The river width will definitely increase, and
Yes, the funneling effect, what we tell it, accelerate and deaccelerated zones. So
yes,
that what is going to affect upstream as well as the downstream.
yes, sir.
It,
And
it
Dibrugarh,
has started. It has
ye-
already started.
yes, sir.
The morphology. Yes, please.
Uh, and our Dibrugarh Water Resource Department is division has already faced this problem and also
Yes.
facing this problem. Earlier, earlier the problem was there only during the flood season, but now it
Mhm.
has become a what all weather problem.
Yes. Yes. That what I can say. They have been protecting the bank with a geobags. But what I observed is they are not doing a proper geobag placing. So that is what I wanted to discuss. The geobag, if you are putting it, they should have a proper placement. Otherwise, even if you have a low height geobags, it can erode it. It can actually displace to one place. So the some locations we have seen is failure of the geobags because of not having proper way to placement of geobags, which I also part of this downstream projects, the bank protections work of the Subansiri hydropower project. Okay, I almost every years I visit almost all 6 month intervals we visit to downstream of the Subansiri hydropower projects up to the 30 kilometers, both the left and right bank. So we visited. Their protections work is stable as of except in the few locations because geobag and all this technology what with a netting and all what they put it, it's quite stable as compared to the only geobag dumping. It's not going to help it. That is what my point to say it. But more detail I'll commit with a when I will teach it the river training work. Any questions to me? It's now 31. Any question? You just ask. This is interaction. Huh.
Sir, a question about assignment, sir. Assignment we have to submit in handwritten form or
You are online or offline students?
offline student?
Handwritten, handwritten.
Okay, sir.
Handwritten. Otherwise, you see, nowadays ChatGPT is there, so which will be generated within a few minutes only, few seconds. So at
Yes.
least हाथ में लिखेगा तो कुछ याद रखेगा ना. So handwritten. Okay. Mostly encourage the handwritten. So otherwise, the ChatGPT is there. Okay.
Sir, I have already submitted in type
No
format.
problem. No problem. For you, it's okay. It's okay.
Sir, I have a question regarding Subansiri River, sir.
Huh.
Sir, since the dam construction is going on and it's almost, it will be, what I have heard, it will be
Yes.
very soon. It will be operational. So
Then it
what?
started. It has started. It already
Okay, then
started. I think
okay,
350 megawatt generation has started already.
okay, sir. So there was huge protest since my childhood. I have seen those protests uh,
Uh,
by our public, and so many
yes.
the organizations are involved in there. So I just want to know what will be the effect in our downstream, because
See,
it will not only affect its surrounding area, it will affect Dhemaji district, Lakhimpur district, as well as it will affect Majuli district, sir.
Yes. So that let me I tell it one thing. See, if you look at the dam project is coming just a foothill. Okay, let us not divide Arunachal Pradesh, Uri, Assam and all. It is just a foothill of the Himalaya. So we have the lower Subansiri projects. Okay, so lower Subansiri project, if you look at these runoff river projects, that means only they will do the ponding for a few hours, not for constant ponding, and they are diverting it, and then they have the hydropower generations. The target is 2000 megawatt, but as of now, I think they have something like 800 megawatt also enough for them. Okay. So if you look at, there are a lot of study has been done it on in terms of downstream impact analysis, in terms of ecologicals and all the things. But one things I'll say it, which I is also part of that, the downstream from the Subansiri, downstream up to the 30 kilometers, they have a very good embankment plus the bank protection work they did it with a geobag and all, which is very costly. It's not close to 20 crore per kilometers. Okay, that means very close to they have spent 3 to 400 crores just to protect 30 kilometer upstreams and the downstream with all the latest technology. That's the reasons both the side the embankment is there, bank protections are there, and they have given enough space to river to have a oscillations basically river has to oscillate it. They have given enough space for the transverses oscillations for the river. Another things what I have seen it, especially I think I can say that left bank of the Subansiri rivers, which is, I think, Dhemaji. Is it correct, no? Left bank belongs to the Dhemaji districts, no?
No, sir. It belongs to Lakhimpur, sir. Lakhimpur district.
Okay. So what I saw it, because of this embankment, COM road, which is really now the facilitating the people. And many of the places, the people are maintaining this thing, because a geobag, if somebody want to do a mischief, they can do easily the mischief to geobag, just to cut it. No, once you cut it, nothing is there. But somewhat this NHPC, they try to accommodate this with a village people such a way that this is the protection system for them. So that's the reason people are not doing any mischiefs like cutting the geobag and all the things. So that's a good things they have done it. So that's the reason over the geobag now the vegetation already has come up. So river is already, bank is almost in a stabilization phase. It's a costly, but it's a stabilization phase. So downstream impact will be not after 30 kilometer will not be much. Okay, but I think this Lakhimpur district MP as well as the CM already declared it to NHPC that they will extend the same bank protection work up to Majuli. Okay, that's what the discussion is going on. But who will implement? Because that's itself another 400 to 500 crores. Who will pay and who will be implement it? No doubt NHPC will implement it, but there still is going on who will be funding that much of money. So one positive thing is that because of NHPC, I'm not supporting NHPC, they have brought the technology to the Assam with a really cost of 20 crore per kilometer, which is Water Resource Department cannot think of that much of money to spend it. So that's the reason it's stable. But no doubt we should, with the time, I believe it will have the cost of the things will be the cheapest. But still, I believe it, embankmenting, if we are doing it, we have to give enough space to river. Plus, you should have the different mechanisms. Otherwise, the mistake as you did it, Niyajati Gogoi said it, that when you do the embankment of river, especially this tributary, northern tributaries, okay, our Brahmaputra rivers, so we are having some sort of attracting a bomb, okay, anytime can explode it, anytime can do a sand casting. That's what I've seen it. It is not a fraud problems. It will be just sand casted, maybe 4 to 5 villages. So they will lost land, they will lost houses, everything they lost it. I think Gogoi can share that part. Sand casting is the biggest issue, not the flood. Flood will come and go, but sand casting.
Yes, yes,
So
sir.
that's what is the bigger issue.
Yes, sir. The entire agricultural fields, they are covered with
Yes,
sand, and you will not able to
yes,
cultivate it for next 10 to 12 years, sir. What I
yes,
have seen, sir, there was a flood in 2000, around 1999 or 2000. So
yes,
whatever sand deposition happened, those
yes,
agricultural field became cultivable after 20 years, sir. And
yes, correct.
even whatever the vegetations that are growing in those land after 20 years,
Yes,
they
yes,
are they are like those grasses which actually grows in sand. So
yes.
it takes time, sir. People really suffers actually.
Very simple way, it's a desertification. In a Assam, creating a desert, okay, is a all the exact word is a desertification. Because of man-made desert, we are creating it. There is no value of that land. After the 20 years, you can grow some on the desert, whatever the type of vegetation being grown it. So there is really huge issue as we discuss it, and I think we are coming close to 1 hour, so I can have a 30 minutes presentations. Let me I share my PPT. Is it my screen is visible?
Yes, sir.
Okay. So this is the class what today we uploaded. Okay. So there is this some part of remaining. So that's what I'll be discussing very briefly about braided system, river systems. Okay. Uh, and so basically, if you look at why why does the river bread forms happens it, okay, that is biggest questions, okay. So basically when you have a high energy dissipations, okay, those is are instability of multiple channels to be there, because the range of the variability of discharge also, or the variability of the stream powers. For examples of the Brahmaputra rivers, at Guwahati, I'm talking about, at present discharge in the month of the February would be 2000 to 3000 meter cube per second. Okay. So you can convert it, what will be the steam power for that. Okay. So WQS, S is more or less a constant. So that means Q equal to 2000. But if you go to average discharge at the Guwahati can go close to 20,000. So that means 10 times more energy dissipation happens it from lean period to the average flow. And when you go to the bank full discharge or the 2-year return period discharge, it could be 30,000 meter cube per second. And when you go for 100-year flood discharge, it is around 66,000 cubic discharge. So that means the same river has to carry or has to energy dissipated 33 times from lean to 100 years return periods. Because of so much discharge variabilities are there, as well as the sediment loads variabilities there. So river doesn't have a confined. Apart from this near the Sareghat, other river banks is totally erodible bank. The bank doesn't have a much strength. So in that case, channel has to go for a braiding pattern. As it's already discussed it, when you have a channel is a braiding patterns, channels will be changed. The confluences, the bifurcations will change, the mid part will be changed. All this process will happen it as at the seasonal level, annual scale level, even if in some cases, if you have a high flood event comes it, that also changes it. That's what I discuss with the Inland Waterways Authority, which is responsible for a river navigations, and they do fortnight river survey from Dhubri to Sadia or Dhubri to not the Sadia up to Dibrugarh. They do it, not beyond the Dibrugarh. It's not possible. So that what clear cut indicates, or many of the time they said it, that the river is so dynamic that one flood wave can enough to change the thallic line. Because when they do the river navigation, they try to find a thallic line, the line of a deepest, line of highest depth. So they travel with it on a thallic line. When return from the Dibrugarh, thallic line shifted. That's the reasons. If you go for a river survey, you can see you have a signal post in a highway. Similar way, the light signaling system is there to representing thallic lines, representing the channel which is active channels having a depth more than 2 to 3 meters. So the ship can navigate it from those reeds. So you can see that high stream powers, erodible bank, a lot of bed load because of upstream as well as the bank erosions, and this we have a very, very fine sediment in terms of silt or fine sands. Okay, that the compositions what we have. Second things what I'm putting it, call it braiding intensity. Call it braiding intensity. Just I'm putting it. I'm audible, no?
Yes, sir.
Okay.
Yes, sir.
Okay, so as you know it, the Brahmaputra is totally braided. There will be a multiple bars are there. So what we do it for a particular stretch of the river, like a 10 kilometer or 20 kilometer stretch of the river, we compute each bar length, L1, L2, L3, L4, you can see it, and do summation of the length of the sandbar, 2 times of that, divide up the length of reach from this length of reach measured on the midway between the banks. Okay, so this is what called braiding intensity. That's what is braiding intensity, 2 times the sum of the length of the sandbar divided by the length of reach. So more the braiding intensity, that what is showing more braiding pounds are there. See, if you look it, it is 90 degree from above of Jogigupa, Pandu, Silghat, Salmora. Okay, so you can see that we are moving to upstream directions. Okay, Silghat is in Tezpur and Salmora, these locations. This site is a breeding index. Okay. So you see this breeding index part, okay, how this value is varying it, and the channel width. So clear cut in indicate is more the widths, more the breeding index is happened. Okay, so the locations of this is the east longitudes. Okay, that's what is in a degree format. Okay, this is the uh, downstream. This is the what the upstream part. So it is showing this variability in terms of braided belt width, the bank, left bank and right bank. What is the distance? If you look at that, this scale is up to 14 kilometers. Okay, and the breeding index, that's what is varies from 2 to as much as up to the 60. Now further, if you look at how these variance things happens, how the breeding pattern started. See, if you two channels are converging it and meeting it, confluencing it, what it happens it because of high energy, both is a create a large the vortex. Because of the large vortex presence is here, because the two flow is meeting it, they do a scouring here. So they erode it, lead to a scour. As it's lead to the scour, these scour materials, river cannot take it further downstreams. So it start depositing in nearby. With a slowly, the depositions develop it and forms a bar. And as the bar formations, bar also grows it. So this is a very simple way. First, it present a scour holes when a two localized flow converges. Then the scour hole materials, whatever the bed materials, eroded materials are there, that's what is transported as a bed load and deposited when flow becomes locally incompetent or locally doesn't have that much of velocity and the bed shear stress to carry further downstream, then it start depositing. So bar formation started. Like this is a point bar formations. Sometimes it can overspill it, then we can have a middle bar formations. So bar formations is a part of the process what it happens it, and this is what is showing it. A particular year, okay, we used to monitor the Brahmaputra river so openly. Okay, nowadays we have slight bit confined with our channel studies. But earlier we used to work very hard for understanding the river. So if you look at this way, this is the May month, the pre-monsoons. Okay, 750 meters this thing. After the monsoon, you can look at that locations. This is what digitized part, the blue colors. So it has created the middle bar. It has created, this is the red line. So you can see this red line is here. And there is a formations of these channel bifurcations happening. Just one monsoon. So this is what dynamic is there. Same way, when the big bar formations are there, if there is a large flood comes it flow over the bars. As it flow over the bar, it can actually dissections of the deposit bar into fragmented small bars. That's what it happened. And this is what it happens during the high flood periods. During the high flow periods, like a 10-year flood comes or 20-year flood comes, then it can go over this. And that water can split it, and slowly the channel formations will happen. The flow will be more centralized directions. The chute formations will be there, and that what will be split it like this. Okay, so this is single bar deposit. That's what is a split it to make it deposit by scour channels. This type of scouring channels will be there. This is what one behavior is there. This is the most interesting part, I think. Is it I am audible to all?
Yes,
Yes,
sir.
sir.
You're audible.
Yes, sir.
Yes. This is the figures I'm showing for Majuli Island. Okay. And and these color represent deposition, these color represents erosions. Starting from 1985 to 2015, okay, almost 15 years, 30 years, no? This is the conditions. This is 85 to 2005, 2006 to 2015, 2001 to 2005, 2006 to 2010, 2011 to 2025. Is there any similarities there? Just check it. These are all derived from satellite data. It's a very easy to do it. Where the depositions happen, where the erosions happen. The first one showing it the difference in 30 years, 1985 to 2015, 30 years. Okay, wherever the depositions are there, these are the deposition, these are the erosions part, okay. And these blue colors are same maintaining channels. This is 85 to 2005, so that means it's a 20 years slice. This is the 10 years. This is the 5 years, what do we have? Can you interpret it from this? Anything we are getting it from this river? Anybody? आई थिंक एम एफ हुसैन होता तो उनको जरूर एक पद्मश्री अवार्ड मिलता है ना, क्योंकि ये जो आर्ट है कोई समझता नहीं है ना.
Yes, sir.
This is what the Brahmaputra rivers. The art formed by erosion's deposition, we cannot understand it. You see the decadal forms. Look at the 30 years formed. How these depositions, erosions are doing it. But one thing is very clear, in this river, the deposition erosions happens mostly in transverse directions. The river doesn't carry much longitudinal directions. So that is what you can see. The figures of these ones, each one is totally different. How the erosions and depositions are happening. Except this blue color, deep blue colors is a channel which is there in the both the periods. Otherwise, erosions, deposition, erosion, deposition, erosions, depositions, all you can see it. What it indicates for us? Anybody can help? क्या समझता करता है? The book what we studied from river mechanics, from Julian book, okay. Last time anyway, the Chinese is really made it me too complicated with the mathematics and our sediment transport and all. Uh, do you believe this river follows any mathematics?
No, sir, not at all.
Anybody else?
Sir, for our Brahmaputra River, there should be new books, sir. Especially for our rivers.
Yeah, correct. So anyway, I'll try to look it. Okay, that's a good suggestion to me. Okay. Anybody? Any offline students? ओके बोले कि 7 तारीख रात को 8 बजे पढ़ाते हैं, सुबह 9 बजे पढ़ाते हैं, है ना? Any offline students by running BTech MTech students? Just interact it. Any offline students? Any MTech students? Just ask some question. नहीं तो मैं सोचूंगा कि you people are just log in. I am audible or not audible to my MTech students?
Audible, sir.
Okay. So what is your view looking these depositions, erosions patterns of Brahmaputra River at Majuli Islands with different time slides? Do you believe this river follow the Saint-Bernard equations? One-dimensional flow? MTech students. Can I use the one-dimensional Saint-Bernard equations to do a hydrodynamic study? Yes or no? MTech student. कोई भी पूछो भाई. हाँ. Yes or no?
Sir, nota.
No, sir.
हाँ, एक से बताओ है ना. हाँ, just हाँ. What are the problems with the Saint-Bernard equation solutions for this Brahmaputra River as showing this erosion and deposition zone? What are the issue? Anybody? Any MTech students or any online students? Online student already you learned na Saint-Bernard equation?
Yes, sir, last semester.
Yes. Did you believe the Saint-Bernard equation is enough for us to find out this hydrodynamic behavior of Brahmaputra River?
No, sir.
Okay. Because flow, if you look at totally two-dimensional natures, with that it is very complex in terms of erosions and deposition. The cross-section changes it. So that's the reason use of Saint-Bernard equation to solve this Brahmaputra River. I think, है ना? क्या बोला जाएगा exact word? So because the river, yeah, please.
Sir, I think we should have our own equations. Sir.
Yeah. Yes, good. So we should have one equations, one models and all. Okay. So otherwise, see, I can run a models. Any model runs, it gives some results. Okay. Like you go to anywhere and purchase a cloth. Okay. So that's the same things. Okay. So and amount of erosions depositions happens. We run some models, two-dimensional model like CC Study and all. Still, I believe this type of process to define it's itself, it's a very difficult. So that's the reasons whatever the water resource department has done it. I think in Majuli, water resource department also try to protect the Majuli. Okay, I was a part of that also in a technical evaluations committee in 2015 to 18. I also went to Majuli and all. I was a part of that 12 kilometers revetment work of 250 crores. Okay. Anybody from Brahmaputra board? I think nobody is there, no? Brahmaputra board, anybody is there in online? Course
Sir,
registration.
they are not taking this subject, sir.
अच्छा ठीक है उनको तो रिवर ही पढ़ना चाहिए था रिवर छोड़ के वो दूसरे के सब्जेक्ट पढ़ रहे हैं anyway so see this is the course you should learn more, no? Yes or no? Brahmaputra boards, whoever the engineer, they should learn Brahmaputra river more, no? Other hydrology, hydraulics system, socio-economy, वो तो चलता रहता है. Okay. So what it's really indicating is that it's a very complex rivers, and it tells us that this river we should look it in different way and different process should be understand it, and we have not understood about this river. So that is the reasons I intentionally keeping this slide you to just think it how this dynamic the Brahmaputra rivers in a 30-year slice. Okay. Now we can go up to 2025, which will be 40 years data. You can see it how the river is dynamic there, and the river protection work, like there is a land spur is there. Also there is a rebatement constructions happens in Kamlabari part. Okay, there are land spots are there. So a lot of activities done by the Brahmaputra board, state waters department, just to save the Majuli or just to save the pneumatic hut part. Still the issue is going on, and there are partly success, partly failures. What do we have? So now I'll be this is what I think my students, the Binay Chambulu did it. Just if you look at the 19th February 2014, the 6th February 2015, 15th May 2015. So 19th February, it's a dry season. There is 2 bar is there, and this is the thallic line. This is the deepest channels. 6th February, within a 1 year, the bar has grown it. Thallic line, what is was there in the left side of the river, now it has gone to right side of the river. So this side, it has changed. It has changed from left to right side. This is 6th February. But from February to the May, during the dry periods, also river has changed it, if you look at it. So this is what is showing it, and there is a channel formations are here. So how within a year change, within the year, with the 6th February 2009, 15 February, 15 May, you can see these are dry periods. The dry period are just pre-monsoons waters. That's what is changed here. These are the transect. We did a IDCP survey. Okay, this is the part you can see it of May 2015 data set. So we can see a lot of observations of these ones. This is quite interesting. I think this is the part of the figures what the Gogoi and the June 2 this is the same figures. Basically, if you look at the braided belt width, average width, okay, 6.79, 11.7, 4.2 kilometer range, standard deviations, average slope, okay, meter by kilometers, okay, that's what is there. And it's average steam powers, if you look at watt per meter square. This is specific steam powers. Okay, that's what is here. And these are the moderate intense braiding and strength. This is what is there. So this is showing a typical cross sections. What is will be the pre-monsoon, monsoon, and dry period can have only two channels. But during the monsoon and pre-monsoon, how this is changing it. Any questions? No questions. Good. This is a very typical work. We did it. I think that is the paper what I have given to you, talking about instability of Brahmaputra rivers after the 1950 earthquake. And this is what we started from upstream, and this is the downstreams, okay, from Sadia to up to the Dhubri, and intermediate like a Jorat, Tezpur, Guwahati, Golpara, this part. The data what you analyze from 1940s to 2009. Okay, now we can add another 15 years. So close to 90 years data we can analyze it to show it how breeding index changes it, island density, number of island per 10 kilometer reach. That means if it's a 25, that means 25 number of islands there for a 10 kilometer stretch. Highest is here is 35 islands for 10, just downstream of Golpara is Dhubri part. Huge number. So breeding index, if you look at that, the where it is, so more or less is breeding index will be the more the islands part is there. And similarly, where you can see it, braided belt width, okay, which is go as much high of 18 kilometers. And the lowest at the Saragat Bridge, which is 1.2 kilometers, the braided belt width is this. So if you look at the 1940s data, see, more or less river was close to the 4 to 5 kilometers. It clearly indicating that earlier used to have a single braided meander channels, meandering channels of a width up to 4 kilometers. 1940 data, if you look at clearly. But because of 1950 earthquake as well as the deforestations and all, so he changed. The river has responded to that change. Okay, river has to respond. I tell it in a geography. We should look at Newton's third laws. So any action there is a reactions. The action is the 1950 earthquake or the deforestation. Reaction, it has changed river morphology. It has changed the braided belt width. It changes from meanders, large meanders, to the braided systems. It has changed from an average width of 4 kilometers to now 8 kilometers. So that way, it has changes this one. Just a few minutes, I will be charging this one. Any questions? Yes, please ask. Yes. If no questions, I think we have only 4 to 5 minutes. This is the erosion's depositional patterns, okay, for multiple bar and the deposition mechanisms. And this is the hypothesis what we are talking about, having a multiple braided bar with the channels which created a 2-bar concept. That's the reason the width has increased from 4 kilometers to 8 kilometers, because earlier it used to have a mandate channels with some locations bar formations, but now it has the 2-bar formations, 2 width of bar formations. That what the hypothesis what we have been testing it. Any questions? Otherwise, I'll stop sharing it and come back to. It's 8:30. I know it. Anna? Any questions? Otherwise, I'm audible or not audible?
Audible,
Yes,
sir.
sir.
Okay, good. So, so if there is no questions, okay, it's already tired. Okay, I think today morning we started the class at the 9. Okay. So with this, let's have, I can close today class. Yes or no? I'm stop recording it. Okay, have a good night.